Hey, good morning, everyone. My name is Toshal. I lead the observability services go-to-market at AWS. I've been in AWS for over 2 years and always been in the observability field.
Hello, everyone. My name is Kumar Jagannathan. I'm a principal solution architect at AWS. I focus on open source observability. I work with customers, help them adopt open source observability solutions on AWS. I'm pretty excited to be here today.
Good morning, everyone, and welcome to the AWS Online Tech Talk. Today, we'll show you how you can accelerate observability adoption using AWS open source observability services. As we just introduced myself, my name is Toshal. Along with me, I have Imaya as well, who's going to be my partner in crime, and he's going to show you some cool demo as well. So let's get started. Today, we will cover some drivers for observability. We'll also look at some popular open source tools. We'll also give you some brief introduction of various AWS open source observability services, primarily Prometheus and Grafana. We'll look at some of the key use cases, how our customers are using the services as well. We'll then follow up with a cool demo, which Imaya will also show us that, as well as we'll have a live Q&A at the end of the session as well. Feel free to ask any questions using the Q&A button, and we'll cover them at the end of the session. And for any reason, if you need to drop or do not want to stay for entire sessions, you can also meet us next week at KubeCon. Both Imaya and I, along with our services team, will all be at KubeCon. So looking forward to meet some of you there as well. So what are the enterprise business goals? As a business leader, one need to focus on the strategic objectives that are most important to the organization's success. You need tools that allow you to have visibility. You need in your applications, your user experience, how users are behaving, to ensure that your organization can effectively deliver against the strategic objectives. What are those objectives? Well, the most basic one is grow new revenue streams. You want to test and reiterate new ideas, create new products, services, reduce your time to market. You need tools that allow you to collecting, interpreting, and learning from your customer data easier so that you can make better, faster decisions on how to improve the experience and create better customer solutions and outcomes. You also want to increase the operational efficiency internally. You want to realize business benefits beyond just the cost saving. You want your IT and R&D staff becomes more productive. You want to gain new agility of your financial, human, and technical resources to meet challenging market conditions. Last but not the least, lowering your business risk. Every industry has its unique source of risk that can affect supply chain, product quality, brand, financing, customers, partners, etc., etc. And as more of your operations, product, and services rely on digital technologies, your business value also depends on managing availability, security, and compliance risk. So first off, I think we all should recognize that there is no such thing as application that never fails. One that always keeps on running whatever happens. There's no such thing. As our famous CEO, Werner Vogel, said, and often loves to say that everything fails all the time. So we must assume that whatever we are building today, that needs to deal with the failures. And often exactly when you don't want them to happen. Interruption can cost a big amount. It is not just the monetary cost, it is also the cost of downtime. We have seen the cost of downtime could be anywhere between $5,000 per minute or 238 minutes per day. In addition, the time to get started back up after the interruptions consume a lot of time, the engineering, the operations time. But the most importantly, the time lost to stress and fatigue, still another 50 to 50 minutes a day or an hour or 2 hours a day. That's a lot of costs, and most of them are hidden costs which are not recognized today. So, what can you do? Well, knowing your application is performing correctly is also a monitoring more than just failures. You want to know, is your application actually performing as expected? Even if your monitoring dashboard is all green, are your customers getting the user experience you want them to give? And they expect it as well. What's the usage of your application? You likely want to know how many people are signing up or how many page views you are getting. What parts of applications are you hitting limits or congestion? The most important, what is the business relevant information? What's the revenue being generated? From what geographic regions are you seeing the biggest growth? How an outage of a particular application affect your business? What trend can you visualize and plan for? Monitoring more than just a service level agreement, but also you need service level objectives. So that brings me to the question, why monitoring is important? First, as we saw in the previous slides, it's about giving yourself as developers and operators visibility into your applications and resources. What are they doing? Second, having metrics gives you confidence that when you make code deployments or infra changes, you can see the impact of these changes and troubleshoot any issues in real time before you hear it from your boss. Third, well, today's reality and the way of we doing business, that customers are very local and internet is a perfect broadcasting medium. The last thing you want is to find out about a problem from your customer. But let's face it, customers expect uptime and they expect a good application experience. Think about yourself as a customer. How many times did you stop midway in an online purchase because the website took long? Or stop using an app on your phone because it was always either crashed or forced weekly updates? Bad customer experience are viral. The last thing you want is to find out from your customers, because not only will they not return, but they may also convince your other potential customer from ever trying to use your app. Last but not the least, application performance and uptime has a direct correlation to your business bottom line, because customers have 10 or 100 or many options that do the same thing. Customer can quickly move on to the next shiny thing. So how do you ensure that you have a proper visibility into your application, your infrastructure? Observability gives you that ability to effectively detect, investigate, and remediate. This can and should improve your operational availability, that is, reduce mean time to resolution, or MTTR. What is the cost of operation failure to your business? That is why observability is so important. You want to detect, investigate, and remediate. AWS monitoring and observability services help you maintain SLAs by detecting, investigating, and remediating problems to achieve. The foundation to observability is metrics, logs, and traces, as most of you would know. They are equally important and are a key component to observability. Metrics are useful for identifying trends, modeling, and prediction. Logs are useful for uncovering emergent and unpredictable behavior. Traces are different. They are user-centric. Logs and metrics are system-centric. They provide visibility into path traversed by a user. What's been happening in last couple of years, or last few years, I would say, is a lot of open source tools are gaining a lot of popularities. Some of them you might be familiar with. You can see it on the screen. You might ask why this is so popular. Well, some engineers or some developers like no vendor lock-in. They don't want to stick with one vendor. Open source gives them that freedom of choice. Also, open source tools are very popular. It's a DevOps community. It's a wide variety of community. One can just quickly reach out to the community and get an answer. And all of this is driving the open source tools and adoption as well. You know, the CNCF project, all the projects, KubeCon is happening next week. And that's the mecca for all the open source community as well. But there always comes a challenge with the open source tools. Managing storage, API, availability, scalability, managing the governance policies. Engineering spend time to optimize memory and compress storage to reduce the cost and improve query time performance. Some of this might resonate with you. Iterative work in building, patching, and upgrading compute nodes. Implementing governance policy to enforce authorization on querying. You're always making sure that it's secured and none of the unauthorized users are accessing this setup. And let's face it, if you are an enterprise, there's no support. You're always reaching out back to the community. So we as AWS has solved the problem. We are offering various open source observability managed services. They provide various benefits, right? We as an AWS, as you probably would know, we always have a security first model. We take security as the most and top of our priority all the time. But our managed open source services also give you scale as you grow model. So as you start to grow, we will auto scale. So you don't need to fiddle with whether I have enough compute or memory. It also provides seamless integration with the other AWS services, such as SNS or identity services or IAM services. Last but not the least, because it's an open source, we are also ensuring that whatever the changes we are making, we are contributing back to the community. It's part of the open source. For an example, Cortex. All the changes we are making in the Cortex project is going back to the community as well. So it's available for anyone to use it in the open source way as well. Let's look at some services, right? And then I'll hand off to Imaya, and he will give you the more meaty stuff on the use cases and the demo. So first one is the OpenTelemetry. OpenTelemetry is a CNCF project. It provides the open source way an agent and libraries and a data protocol to unify monitoring and managing and debugging applications. It has support for metrics, logs, and traces now. We, as an AWS, are committed for this project. And we are also an active contributor to the project as well. But to help the community, we are also providing an AWS distro for OpenTelemetry, or ADOT as we call it. It's an upstream version. It's not our fork. But we are also making sure it's a secure and production-ready distribution supported by AWS. So free of cost. Anyone can just go and download that and can start using it. And if you need help, you can always reach out to the AWS for any help. So now you have a best of both worlds. You have an open source tool, which is free, but you also have now a support model provided by AWS. Built upon that, we also have Amazon Managed Service for Prometheus. This is built on Cortex as a backplane or data plane. It's a serverless Prometheus compatible monitoring service for metrics to securely monitor your containerized environment at scale. Because it's the same open source Prometheus data model and a query language, you can use your existing tools and the query language you have placed and simply switch to the Amazon Managed Prometheus. Because it's an AWS service, you have the availability and security. It's a fully available service. It's a managed service. But you also have the scalability. As you start to have more workloads, we will auto-scale behind the scene. And it's a no upfront investment. You can use it as little as you want or as much as you want. You only pay for what you consume or how many, in this case, the metric samples you ingest. Last but not the least, Amazon Managed Grafana. Similar to Prometheus, we worked with Grafana Labs to offer Amazon Managed Grafana for the open source Grafana. It's again scalable and secure and highly available, similar to Prometheus service. But we also give you an access to the enterprise data source in partnership with Grafana Labs. It also allows you to auto scale. And this also helps you with the offload operation management. Because it's an AWS service, you have a native integration with all the other AWS services as well. So you have all those data sources available in Amazon Managed Grafana of AWS services, but you also now have a dashboards. So with a simple click, you now have the ready-made dashboards available. It's also a very simple pay-as-you-go model. More you can find it on the website as well. Okay, I'm going to hand off to Imaya now to dive deep into some of the use cases as well as the demo. Imaya?
Thank you, Tushal. So customers use all types of compute environments to host their applications, depending on their needs, whether it is Amazon EC2 or they use the container orchestration services such as Amazon ECS, EKS, or ROSA. There could be also serverless applications that are hosted on AWS Lambda or using container serverless environments such as AWS Fargate, or even applications hosted on on-prem environments, or including solutions such as EKS Anywhere. Customers have different needs, but observability does not change whether what the environment is or where the application is hosted. You still need to have visibility into your application performance, health, and how efficiently your resources are being utilized by your application. Let's take a look at how you can configure data collection on Amazon EC2, for example. In this diagram that you're seeing here, we have EC2 instances, a couple of them, and you can see that I have the ADOT Collector that is deployed here. And the ADOT Collector is the AWS distro for OpenTelemetry Collector that can collect metrics and logs, metrics and traces at the moment. And in the future, it will also support logs. So you can use the ADOT Collector to collect Prometheus metrics, for example, from your application endpoints that would have custom business application metrics that are being exposed in Prometheus exposition format. And you can also collect the EC2 instance performance and health information through something such as a node exporter that would allow you to get information about how much CPU is being utilized, how much memory utilization is going on, and so on. And you can send all of that information through a VPC endpoint securely through Amazon Managed Service or Prometheus Workspace. And from there on, you can visualize through Grafana and also can get alerted from Amazon Managed Service or Prometheus Workspace to your destination of your choice through Amazon SNS. So this is one of the examples. So another architecture design could be something like this. Here, as you can see, I do not have the ADOT Collector deployed in every single EC2 instance, but I have the ADOT Collector deployed in just one EC2 instance, whereas it is being configured to go reach into different destinations and scrape data, Prometheus metric data from all those endpoints. Prometheus natively supports EC2 service discovery configuration. And because of that, the ADOT Collector, the AWS distro for OpenTelemetry Collector, also supports EC2 service discovery. What that means is the ADOT Collector can automatically identify the EC2 instances that are being spun up through auto scaling, are being shut down. It will and ignore the targets, and it will automatically be able to reach into those targets without you having to manually edit the configuration. So this would be probably a little bit more advanced configuration than what I showed earlier. Here's another example. The ADOT Collector doesn't mean that it only can send metrics to Amazon Managed Service for Prometheus. You can also use the ADOT Collector to send metrics and trace information to other destinations as well. For example, in this architecture diagram, you can see that we are using the ADOT Collector to send the metrics to Amazon CloudWatch through embedded metric format technique. It is basically a methodology that is used to send the metrics to CloudWatch from environments, from ephemeral environments primarily, to collect metric information through log events. So you would send the metric information in a specific structure to CloudWatch logs. And from there on, CloudWatch logs will pick up those log events and extract metrics out of them and put them into CloudWatch metrics. So this is one of the other architecture. Let's take a look at how serverless environments can be monitored. For serverless, primarily for AWS Lambda, there is a stripped down version of AWS distro for OpenTelemetry Collector available, and that collector can be deployed as a Lambda layer. When you deploy the Lambda layer, it is automatically configured to operate in a Lambda environment and can accept trace information from a Lambda application without you having to do too many changes. So it will be able to collect traces from your Lambda functions and send them to AWS X-Ray. When it comes to Amazon ECS, we have in the new console experience, you have a really easy way to collect metrics and traces from your ECS tasks. In the new ECS console, you should be able to, when you create a task definition, you should be able to see options to collect traces and metrics using the AWS distro for OpenTelemetry Collector. The interface will guide you through the process, and you can specify the endpoints at which the metrics and traces are available, and the ADOT Collector will be configured to reach out to those destinations and collect that information. You can also configure this to collect both traces and metrics. You can also deploy the ADOT Collector to collect infrastructure metrics using the AWS ECS Container Metrics Receiver extension. It is an extension that is available in the ADOT Collector that would allow you to automatically collect infrastructure metrics from your ECS clusters. You can also discover and scrape Prometheus targets using the ECS Observer extension. So this is another extension that allows you to get custom application metrics, for example, from Prometheus targets. So you can collect those custom business metrics, and you can understand how your business performance is through the ADOT Collector as a collecting agent. For Amazon EKS, there are multiple ways for you to deploy your collector to collect metric information. In this example, or the architecture that you see here, although it looks complex, but you can see that here every single pod has an ADOT collector deployed as a sidecar, and this is one of the ways that you can actually deploy to collect metrics and traces from your workloads. So in this example, the ADOT collector is only scraping the local host in the pod's metric endpoint, and it is collecting all the information, sending them to managed Prometheus service through VPC endpoint, but also the application is configured to send traces to the ADOT collector, and those traces are being sent to AWS X-Ray. Both traces and metrics in this case are being visualized using Amazon Managed Grafana. This is the sidecar pattern. Next, we have the Daemonset pattern, where we can deploy the ADOT collector as a daemon set in each EKS node, and the load is evenly distributed across these ADOT collectors that are deployed in each node, because the collectors deployed as daemon sets on each node are only going to use metrics or scrape endpoints that are in the same node. Any metric targets, any Prometheus targets that are not in the same node will be ignored. So you will have even distribution of load distributed across the ADOT collectors in your cluster. And you can also use the same ADOT collector to collect traces, just like we saw in the previous example. You can also have a deployment pattern. Here, it might be one of those options that you could use for a smaller clusters, a smaller EKS cluster environment, where you will have a ADOT collector deployed as a deployment, as a single deployment or more than one deployment. But that is the only one that is going to scrape all the endpoints from all the different pods. It could be your application metrics, or it could be you collecting infrastructure metrics through node exporter or cube state metrics or anything. But there's just one ADOT collector that is collecting all those metrics and sending to managed Prometheus service. There is a chance of single point of failure in this option. That is why you want to look for high availability for ADOT collector. ADOT collector can be configured, or in other words, you can configure high availability using the ADOT Collector or even the Prometheus server when you're collecting Prometheus metrics and sending them to manage Prometheus service. In this example that you see here, you can see that there are two copies of the ADOT Collector. And the way they're configured is we have external labels that are added to those replicas. From in one of the first replica one, as you can see on the screen right now, you will add external labels to determine that those two replicas are part of the same cluster. So you would say cluster, you'll have, in this case, we call it monitoring cluster. And in replica one, the replica label says replica one, and you will have the other deployment of the ADOT collector that will say replica value as replica two. So when Amazon Managed Service for Prometheus receives samples for all the metric series that are being scraped by these collectors, it will automatically do a leader election process. It will select one leader and only accept metric samples from one source. And when the source stops sending metrics for about 30 seconds, it will automatically switch to the other replica and continue accepting samples from that replica until something happens. And at that point, it will again switch back to the other replica available. So here, this avoids the single point of failure scenario that we saw earlier. Now you have high availability of the collection process. But at the same time, while you're sending the metrics samples to the managed Prometheus service from both collectors, because the Amazon Managed Service for Prometheus automatically filters the samples out and only accepts and ingests samples from one collector, you are not going to be paying twice. You will be paying only for one ingestion. The other option for you to deploy the OpenTelemetry Collector is through the OpenTelemetry Kubernetes operator. Sometime during end of April timeframe this year, we launched the add-on support for the OpenTelemetry operator. The OpenTelemetry operator is a custom operator for Kubernetes that operates and manages the lifecycle of a custom resource. In this case, it is OpenTelemetry Collector. So you can deploy the OpenTelemetry Collector as an operator, as an add-on, and you can deploy the custom resource, which is the OpenTelemetry Collector, and have the operator manage it for you. One of the interesting things about using the OpenTelemetry operator is that you can deploy the collector as a stateful set, and you can allow the operator to automatically distribute the load of different copies of the collector evenly. The collector or the operator would identify the targets and would make the collectors know about the destinations or the targets that they need to scrape from using HTTP service discovery. Although there are multiple options for you to collect metrics and visualize an alert and so on, although it is made a lot easier than you having to manage your own infrastructure to store, to query metrics and so on, the customers still have some common questions, like how do I deploy the collector? How do I identify my targets? Am I collecting the right kind of metrics? And how do I create alerts? What kind of metrics are valuable for dashboarding? And overall, they're not really sure about whether they are doing it right or not. And they're quite hesitant to adopt some of these services because they're really not sure. So to avoid such problems, or to remove such confusions, we came up with AWS Observability Accelerator. So AWS Observability Accelerator is a Terraform-based open source package that is available on GitHub. And today we support infrastructure monitoring for Amazon EKS, and we also support workload monitoring for Java and Nginx workloads. It is an end-to-end monitoring setup that includes deployment of the OpenTelemetry operator, deployment of the collector. We will deploy some essential components such as node exporter, kubestate metrics, even cert manager to have the operator and the collector work properly, and also have specific targets scraped in the Kubernetes cluster. And we create a bunch of rules that we think it is an opinionated way of collecting metrics. So we create a bunch of rules, and we also create a handful of dashboards on Amazon Managed Grafana. So when you deploy it, you have full visibility into your cluster's infrastructure performance and health. Next, what I'm going to do is I'm going to jump to the demo screen and show how this all is put together. Let's go to the demo screen. So here I'm on the AWS console. I'm on the Amazon Managed Service for Prometheus console. Here, if I go to my workspaces, I have one workspace called Observability Workshop. Inside that, I have an empty sort of workspace where I'm not sending any metrics to. You can see that the rules are empty, alerts are empty. There's basically, I have an empty workspace that I created, and I have not configured any metrics to be sent to this workspace. You can see that there is a remote write URL that is available here, and this is the remote write URL to which we will be sending the metrics to. And here's the query URL that we'll be using to query the metrics from. Okay, I have this workspace, Prometheus workspace created. I also have a Grafana workspace here that is also called Observability Workshop. And here, I don't, when I log in here, I can log into the Grafana workspace through this URL, through IAM Identity Center. And if I log in here, as you can see, I don't have any dashboards. I don't have any data sources other than a CloudWatch data source, and it's pretty much empty. There's none here. So what I'm going to do is I'm going to use my Cloud9 environment, and I'm going to deploy the AWS Observability Accelerator to set up monitoring for my EKS cluster. The EKS cluster that I have here is, let me go to the EKS console, and in my EKS console, I have a cluster called PetSite. And in this cluster, this is the cluster I'm going to monitor. If I go to add-ons, for example, I see that there are no add-ons available or deployed at this moment. The AWS Observability Accelerator is available as a GitHub project in this URL. We will share the URL at the end of the presentation. What I've done here in my Cloud9 environment is I have cloned the project. So what I need to do right now is I need to do a Terraform apply essentially to have the Terraform module basically create all the infrastructure. So to do that, I need to go create one important thing, which is the creation of the Grafana API key. The reason why I'm doing that is we need the Grafana API key to make HTTP calls to this to the Grafana environment. If I go to the API keys here, you can see that I just created an API key, and this API key will be used to deploy the dashboards and data sources and so on. So now that I've created the API key, all I will have to do is simply go apply Terraform, run the Terraform apply command. So I'm going to go here and Terraform apply. I'm going to say auto approve. I'm just going to auto approve, and it takes about a minute or so for the Terraform apply to be completed because it creates a bunch of resources. You can see that it is actually starting to work, and it's starting to create all the resources that are essential. While that is getting created, let's go take a look at the presentation and see what resources are actually being created. In this slide, you can see all the different resources that the AWS Observability Accelerator is creating. We talked about the GitHub repo that we cloned and the Terraform apply command that I ran, and it uses Terraform. So once we run it, it actually goes ahead and deploys the AWS distro for the OpenTelemetry add-on on the EKS cluster. Okay? And once it enables the add-on, then it also deploys the ADOT Collector configuration. It's a custom resource definition. Because the ADOT add-on can manage the ADOT Collector as a custom resource, we deploy the custom resource and immediately with specific configuration that we want, and it automatically starts collecting information or metrics from the EKS cluster. And from there on, it actually is configured to send the metrics to the managed Prometheus service. In the managed Prometheus service, what we also do is we create the recording rules and the alerting rules. All of those are being done by Terraform, by the Terraform module itself. And once those recording rules and alerting rules are deployed, we also create a custom Prometheus data source on Amazon Managed Grafana workspace. And then we also deploy a handful of curated dashboards that are that we think are useful to learn for customers to learn about their EKS cluster performance and health. So through those dashboards, users will be able to visualize the performance and health information of the EKS cluster. The same process works for whether you're using the example of the workload monitoring like Nginx or Java and so on. And in the future, we continue. We are excited to get feedback from customers themselves and build based on what the customers want to see. Since we have seen here, so you can see that it is currently still being deployed. And let's go to the managed service of Prometheus workspace here. As we saw earlier, there were no rules. If we click here, the rules are still being created, I believe. And the alert, there is an alert configuration that has been created, but the rules are still being created. You can see that there's a rule that is currently in progress. The infrastructure rule is creating. The alerting rules are being created. Both are being created by the Terraform module. So if we go here to the Grafana workspace, let's go check if the AWS data sources are being provisioned. You can go to the data sources here. You can see that we have AWS Observability Accelerator data source that got created. Earlier, if you remember, there was only a CloudWatch data source here. I can click on the AWS data source, accelerator data source. And if you see here, it is pointing to the same query URL of the workspace that I showed you earlier, which is here. So this is the same query URL, which ends with DA03. Let's do a quick check on whether this works or not. If I save and test, it actually is working. So we should be good here. That basically means that there is a valid connection between Grafana and my Amazon Managed Service or Prometheus workspace. Let's go check if there are any dashboards are deployed or not. If we go here, you can see that there is a folder now. There's a new folder. Inside the folder, I can see a bunch of dashboards that were already deployed. So let me go back to the Cloud9 console to check whether it is complete or not. So you can see that the deployment is complete. It added 31 resources. So everything is successful here. So now we have the whole setup of the rules, alerts, the dashboards, and so on. If we go here, you can see that the rules are all active. The infrastructure rules, the alerting rules, they're all active. So that essentially means that the deployment is successful. We can also do a quick check on the different types of resources that were deployed. We can see that the Prometheus node exporters are deployed. The OpenTelemetry Collector was deployed, and the cert manager that was deployed. And you can see that the OpenTelemetry, the ADOT Collector was also deployed. So this is the one that is sending all the metrics to the managed Prometheus service. So we have all the essentials deployed now. So now we can go to the Grafana dashboard and check if we have the data. So if we can go to one of the dashboards here, we can maybe go back maybe a couple hours, 5 or 6 hours. You can see that there is data here. So if we give enough time, you will start seeing the latest data as well. So this basically exemplifies that we basically can go and see other dashboards also, but this essentially shows how easy it is for you to almost without having anything. All I did was just clone a GitHub repo and do a Terraform apply, and I have pretty much everything deployed, including the collection agents, to the dashboards, to the alerting rules, recording rules, and pretty much all the entire plumbing was set up just by one command. All right, so hope you like the demo, and you can actually get access to that demo from these QR codes. The AWS Observability Accelerator is the blue one. If you scan that, it will take you to the GitHub repo that I was showing earlier. And all of this is also available as part of the One Observability Workshop, which is a workshop that our team manages. It actually contains a lot of information, which is basically, this is the URL. That QR code will take you to this URL, and here you can actually explore and get a feel of all the AWS open source services and also the AWS native services on how different features work together to give you a full observability environment. We also are going to be at KubeCon North America next week. We're excited to meet you all at the booth there as well in Detroit. All right, thank you so much. Thanks for joining the session today.